that clock signal will change from 0 to 1, and that is called a positive going transition. As you can see, this signal is going from 0 to the 1, so we can call it as a positive going transition. And this signal 1 to 0, so it changes from 1 to 0, then it is called as a negative going transition. You can see the waveform right here. This signal moves from 1 to 0. Okay, so this is a positive going transition and the negative going transition. So we have designed this flip-flop, and how you can give the input, and how you can get the output, and how you can provide the clock signal to this. So there are a number of input signals to the flip-flop, and there are only two output signal. One output signal is Q, and another output signal is Q bar. If Q is 1, then Q bar is 0. If Q is 0, then Q bar is 1. Okay, you have to provide some clock pulses. Either that clock pulse should be a positive going plus, or that clock pulse should be a negative going pulse. We can denote this setup time with the T of S. Okay, so it is a time interval immediately producing the active transition of a clock signal, during which the synchronous input has to be maintained at a proper level. Okay, synchronous control input, or we can call it as a synchronous input also. And when you apply a clock signal, when you apply a clock input to this particular circuit, okay, so it will hold some position from this point. Okay, and it will change to the next level. It will change to the next level. So this point is called a, what we can call it as a setup time. Okay, this particular point, when it starts from this point, this clock signal is provided at this you have provided the input signal as a synchronous input, and you have provided this clock pulse at this point, okay. So when this particular signal moves from this point to this point, this is called a setup time. Okay, this is your setup time, and we can represent this setup time as TS. Hold time can be represented by TH. Okay, so it is the time interval, sir, the hold time. Okay, what is the hold time? It is the time interval immediately following the active transition of a clock signal, during which the synchronous input has to be maintained at a proper level. So you have to provide the synchronous input. Okay, so that synchronous level you have to maintain for a long period of time. It is high, okay, and now you are changing it to the low position, and initially it is in the low, and you are changing it to the high position. Okay, so let's suppose that your transition is happened at this particular moment, and this is the point. Okay, this is the point when transition happened, and at this moment, from this point to this point, what we can call it as a hold time. So this is your hold time. So we can represent it as a TH. The time interval immediately following the active transition of the clock signal, during which the synchronous input has to be maintained at a proper level. Okay, and it should be the minimum, okay, value. Clocked SR flip-flop have the two input. First input is R, second input is S, and one clock signal you have to provide. Okay, when this particular clock signal is provided, then your circuit has to be started. Okay, so one R input, one S input, and this clock signal is to be provided to the inputs. Okay, so this is the clock signal. So your input is to be provided to the AND gate, because you have to start R flip-flop, you have to start S flip-flop. NOR gate. I have told you NOR gate and NAND gate you have to use for this particular circuit. By the cross coupled connection. Okay, so how you can connect it as a cross coupled? The first output of the this and OR gate and NOR gate output is to be connected to the input of the second gate. Output of the first to the input of the second. Yes, you are right. So this is the cross coupled combination you have to create. Okay, Q and QY. Yes, so one output is Q and second output is your QY. Okay, so your input for the first state is to be considered as non-active. Okay, so let's take the combination for this. So clock pulse is 1 for all the 4 cycle. So initially this clock pulse is taken as 0. Okay, so we cannot consider these as R and output Qn plus 1 state. Okay, when clock pulse is 0, I have told you when clock pulse is 0, nothing will happen to the input synchronous signal. When this clock pulse will be high, then your input should be changed to the output and 1 1. These are the 4 possible combination for this one. Your state is invalid. Okay, when you apply the 0 0 input, then its output is, it will change or it will depend upon the previous state. Yes, it depend upon the previous state. Okay, so this will depend upon the previous state. Okay, and what is the output when you place 0 1? So output of a Qn is 0, and when you apply 1 0, then output is 1. So this 0, we can say it is a reset state. Reset, we have to clear the output, and when you say 1, it is a set state. Okay, so we can call this set state and reset state. Okay, and this is your Qn, and this one is your invalid. Here your Sn and this particular Rn. Okay, these are the two inputs, we can say. These are the two inputs, and your output is Qn is your output. You understood about this? Sn and Rn you have taken as input, and Qn is taken as a output. Okay, so n represent the bit time. Okay, during the bit time, or we can say the output during the bit time, or this n will be basically depend upon the time. Okay, so this Qn plus 1, what does this mean? Qn plus 1, this particular Q, after the clock signal. Okay, after the clock signal, it will give you the output as n plus 1 state. Use this S and R as 0 0 0, output is also 0, and what is the output right here? Qn is also 0, and n plus 1 is also 0. And when you use this input, okay, and again you have to apply the Qn value to the 1, okay, then your output is going to be changed to be 1. Okay, so it is changing from 0 to 1. So we can represent this as it depend upon the previous state. This is the first case for the 0 0 input. Okay, let's assume the second case. Let's assume the second case. Right now you are providing the input as 0 1. Okay, right now you are providing the input as 0 1, but what is the output? See the previous table which we have created right now. Yes, output is 0. Okay, output is q and output is 0, and same we will use at 0. Okay, now again, when you apply this 0 1 input, and your this input will change q and will change for the next state to 1, what should be the output? What should be the output? Output should remain as a 0. So we can call it as a reset state. This is a reset state. Okay, this is a should be 0, but qn plus 1 should change to 1. Okay, so this qn is 0 and qn plus 1 is changing to 1 position. Okay, and this 1 0, and this qn we can take right now right here. Okay, and what is the output right now? It is remain as 1. Say it as a set output. We can say it as a set output. Next, we will take input as 1 1, use this qn plus 1 as invalid state. Okay, and when we use this 1 1 as 1, okay, so there are two possible combination for qn. Either it should be 0 or it should be 1. Same thing is happening right here. Either it should be 0 or it should be 1. Same thing is happening right here. Either it should be 0 or 1. Either it should be 0 or 1. So we are using two possible combination for this qn. So if you take these two possible combination, then what is the output at next level? You have to find out using this circuit. Okay, so right here it will not give you the proper output. So we can call it as invalid state. You have to design the K map. You have to design the K map for this particular circuit. R bar, Qn bar, S. Okay, R bar, Qn bar, and S, R bar, Qn, and S. Okay, then R bar, Qn, and S bar, and cross you have to fill across R, Qn, and S, and R, Qn bar, and S. Okay, so where we have to put 1 across this table, you have to put 1 1 1 cross and cross. You have to make the combination like this, and you have to make the combination like this. Qn bar is also changing from this loop. So we will consider only S, and from here you can see S is changing from S to S bar. So we will consider R bar and Qn. So the combination of this K map is R bar Qn plus S. So it is the output, okay, for this RS type of flip flop. So this is the output for SR type of flip flop, and you can see that what are the different disadvantage of this SR type of flip flop. Yes, this SR type of flip flop will provide you invalid state, and to overcome that invalid state we have to use the JK type of flip flop. So what is JK type of flip flop, and how you can eliminate this? You can solve it by using feedback to the JK flip flop. Yes, you are right, Milind. So okay, so circuit is similar. In the SR type of flip flop, you have seen the two AND gate are used and two NOR gate are used, and same this cross coupled connections are provided to the SR type of flip flop. But here we will provide the feedback to this AND gate. Okay, here we will provide the feedback to this AND gate, and it will overcome the invalid state problem. And how you can overcome this problem? Okay, so you have to use the feedback to overcome this invalid state problem. Okay, and one more thing you have to use, that you have to multiply this Q bar with J and Q with K. So how this is possible? You can see right here. This is the output Q bar. So that is multiplied to the AND gate. That means at the input side. So J multiplied by the Q bar, it will give you the output JQ bar. Okay. And from here you can take the feedback as Q, that is multiplied with this K, and you will get output K into Q. And with the help of this NOR gate, you will get the output. Okay, so we have seen this particular truth table, which give you the particular output. So you can see right here, when you apply the 1 1 input to the JK flip flop, it will give you Q bar signal. That is a toggle signal. The first QN signal is the hold. That means 0 0 stand for the hold. Okay, so we have derived the characteristics table for this JK type flip flop. As you can see, we have the combination starting. As you can see, we have 3 input. Okay, so if you have 3 input, but and how many possible combinations are there? There are 8 possible combination, and you can write all these values right from 0. So this is 0 1 2 3 4 5 6 7. Okay, so according to this, you have to design the output, or we can say next state. Okay, so this Qn plus 1 is your next state. Okay, so you can see right here, when you apply this zk as 0 0 and 0 1, you have to take these 2 possible combination. Okay, so from here you will find the first output is Qn, second output is reset state, third output is set state, and last output is toggle. That means you have to interchange, or you have to change the signal from 0 to 1 and 1 to 0. After this, we have designed the K map. So these are the 3 inputs, and we have to find out the one location. So where this one is present, as you can see, this one is present right here, then this one is present right here, and you have to put these one across the K map. So you can see right here J bar, K bar, and Qn. So J bar, K bar, and Qn. This is your first one. Second one, J, K bar, Qn bar. J, K bar, and Qn bar. This is your second one. Third one is J, K bar, and Qn. So J, K bar, and Qn. This is your third one. And lastly, you will use this J, K, and Qn bar. So J, K, and Qn bar. This is the last. And how many possible combination you can make? You can make 2 possible combination right here. So from this particular combination, let's suppose this is your first loop. You have to solve this first loop. You can say see right here, this J is changing. Okay, so this J is changing. That means you have to consider only K bar and Qn. So K bar and Qn is considered from the first loop. Let's suppose that this is your second loop, and from this second loop, how you can define the value? This K bar is changing. You can see right here, K bar is changing. We will not consider K bar. Okay, because this K bar is changing to K, and Qn bar is not changing, and J is also not changing. So we will consider J into Qn bar, and this is the reduction of your K map. And you can see right here, there is one major disadvantage in this type of JK type of flip flop, that race around condition will arise. Okay, when you give the input as 1 1 to this JK type of flip flop. Okay, so what do you mean by race around condition? As you can see, in a toggle state, your output should be changing from 0 to 1 and 1 to 0. Okay, so you can see right here, this is the input signal. Yes, both the input. You can see from this waveform. Okay, so this is the input waveform. Okay, so this is the input waveform, and from this input waveform, your toggle input is present right here. So it is changing. Initially, as you can see, this is your positive edge. Okay, so this, when this positive arises, then your input is changing to high, then another positive edge is arises, then your input is changing to 0, then next positive edge is arises, again this input signal is changing, again positive edge is arises, then again it is changing. So this is called a toggle state. It change from 1 to 0, 0 to 1 every time when positive or negative trigger pulse will arise. Okay, so this signal changes from 0 to 1. and then from 1 to 0 it is changing, then again it is changing from 0 to 1, again it is changing from 1 to 0. So this process will continue. Okay, this is called a toggle state. Now come to the next point. When you apply this input signal and it is changing according to toggle state, and your output signal is changing. Okay, your output signal is changing with respect to this input signal. Okay, toggle input signal. Okay, you can see initially it will take some time initially, and when this clock pulse is started at this particular time, this output signal is changed from 1 to 0. Okay, this output signal changed from 1 to 0. Now this again, this clock pulse is dropping right here. Again this 0 signal is changing to the 1 position. Okay, again you can see right here this clock pulse is changing right here, and when this is changing, it is giving output from 1 to 0. When this next trigger pulse arises, it again change from 0 to 1. So this is called a race around condition type of problem. To overcome this type of problem, we have to use the master slave type of configuration. Okay, so as you can see right here, this is the configuration which is called a master slave configuration. In this master slave configuration, you have to use the two flip-flop. Okay, so what are those two flip-flop you have to use? You have to use either master or slave combination and a inverter. Okay, so what do you mean by inverter? That will invert your output. You have to use that inverter. Okay, so when you apply the positive clock signal to the control input, your output is changing in the master slave. Okay, so as you can see, this positive edge clock is applied to the control input. So this output of a master is going to change as this movement. And when you apply the negative clock signal to the clock of the state of a master, so this is transferred to a slave. Okay, so the output is given as Q and QR. Okay, so in master slave flip flop, output totally depend upon the slave configuration of a flip flop. Okay, so output will be depend upon slave configuration. After this, we have to design the logic diagram for this master and slave type of flip flop. You can see right here, this is the input S, R, and clock pulse. Okay, I have told you what we have to use in this master slave type configuration. You have to use the master, you have to use the slave, and you have to use the inverter. Okay, I have told you, you have to use the master flip flop, you have to use the slave type of flip flop, and one inverter you have to use. Okay, so this input is given to each flip flop. So as you can see, this S and R are the two inputs, and this clock pulse is provided to the master that will give you the output as by and by bar. Okay, when this particular signal is your, what we can call it, quickly give your response, what we can call it, is it positive going or negative going? Yes, it is a positive trigger. Okay, and this is an inverter. Yes, this is a positive going. So when you apply a positive going trigger pulse to this master type of flip flop, it will give you the output. Okay, so it will give you output as y and y bar. Okay, and this inverter is provided right here, so it will invert this input signal. So when it is 0, it is converted to 1, and when it is 1, it is converted to 0. So this signal is provided to the slave type of flip flop. So which type of signal is this? This is a negative trigger pulse. Okay, so signal is changing from 1 to 0. We can call it as a negative trigger pulse, and this one is called positive trigger pulse. Okay, so I have explained the working of this particular flip-flop, that when you provide the input signal and positive going pulse, it will provide the output as by and by bar. And when you apply the negative trigger pulse to the slave type of flip-flop, it will give the output. So this uh, what we can say master slave configuration totally depend upon the slave configuration output. Okay, so as you can see right here, the output is taken from the slave, so your output is equal to q and q bar. Okay, so let's take a first case. When you apply this clock pulse 0, okay, when you apply this clock pulse 0, the output of an inverter is 1, and the slave output is 1 at that point, and the flip flop is enabled, and the output q is changing to by and q bar is changing to by bar. Okay, and the master slave flip flop is disabled because this clock pulse is 0. Let's consider the second case when clock pulse is 1. Okay, when your clock pulse is 1, then what happens? So this particular master flip flop will start, and what will happen? Output is inverted to 0. The master flip flop is isolated, which prevent the external input from affecting it. Take a look on this particular timing diagram, and you will understand from here. So this is a clock pulse. So how you can represent clock pulse? I have told you it is a continuous signal which is represented like this. It is a clock pulse like this. Okay, we can say this is a clock pulse. Then you will set this particular signal to the high position initially. Okay, this is your set signal, and we will provide the by output as a low because your slave configuration is at a low position. Okay, so it is changing when you apply a clock pulse. You can see from this point, when you apply a clock pulse, it is changing. Okay, initially your signal is 0. Okay, when you apply the clock pulse as 0, then it is with the help of this inverter, it is going to change to the 1 position. Okay, so it is changing from 1 to 0. So now this output is changing, and when this output is changing, this signal is given to the q. Okay, q bar. So it will take some time to change the configuration. When this signal clock pulse signal is low, it will change the output to this high state. Initially your output is at low, and when your clock pulse is arriving at this particular buy point, then it is changing its output. Okay, it is a modification of clock type of SR flip flop. So how you can make some modification in the clock SR type of flip flop? You can see right here we are using the AND gate. Okay, and right here we are using the NOR gate. So we replace these NOR gates with the help of NAND gates. Okay, so we are using the NAND gate, two NAND gate right here, two NAND gate right here, and one NAND gate at the this D inverted input. Okay, so you have to apply the D input to this S and R type of the input. So it is a flip flop with a delay equal to the exactly 1 cycle of a clock. It is also called as a transparent latch. Okay, so this is the simplified diagram for your D type of flip flop. So as you can say, you have only one input as D and one clock pulse you provide right here. Okay, so when you apply this input toward this first AND gate, so it is giving you output when this clock pulse is high. Okay, or we can say clock pulse is 1. So then it will give you the output. Okay, after this input, you have to invert your D. Okay, value. Okay, so what is the output right here? This output is D bar. So D bar is provided at this point, and you have to provide the clock signal right here. Then this particular AND gate would work, and accordingly with the help of this cross coupled connections, the output is feedback to the input side. Okay, output is feedback toward the input side, and it will give you the output. So we have to derive this expression through K map and through the characteristics table and the truth table. Okay, so let's understand from the truth table how you can design the truth table of this type of flip flop. You can see this is your D type of flip flop that is designed with the help of JK type flip flop. As you can see, only one input D is provided right here to this J, and inverted input is provided to K, and clock pulse is provided to this. Okay, so there is only two inputs. First input is D, and second input is clock pulse. So we will design the truth table. So your first input is clock, and second input is D. So if you have this input, okay, how you can design your output, you can see right from here. So if you provide input as 0, it will give you the output as 0. If you provide input as 1, it will give you output as 1. So that's why it is called as a transparent type of flip flop. So when you apply input as 0, it directly give you output as 0. When you apply input as 1, it directly give you output as 1. Okay, so that's why it is called as a transparent type of flip flop. So characteristics table, how you can design, you have the two inputs right here. You have the two inputs. So how many possible combinations are there for these two inputs? You can make the possible combination 0 0 0 1 1 0 and 1 1. Okay, so from these two possible four possible combination, you have to design the next step. Okay, so for this we will design the output that for 0 and 1 location you will get 0 0 output, and from this 1 1 and 1 0 location you will get the 1 1 output. For that you have to create the K map. Okay, so at these two location 1 1 position is present. Okay, and you have the two inputs. Okay, you have the two inputs. So how you can design a K map? In one side you place the D, in second place you place the Qn. Okay, so Qn is changing from Qn to Qn bar, and D is changing from D to D bar. Okay, you have to put the value uh, at these locations. Okay, so where this one is present, this one is present at D and Qn bar. So D is present right here, Qn bar is present right here. Then you have to put the one across D and Qn. So D and Qn, this is your one location. So this is one pair. And what is the output for this? If you solve this K map, output is equal to, quickly give your response. D, yes, output is D because this Qn and Qn bar is changing. So we will not consider these things. And only output is D. So it is giving you the single output, which is D. Quickly give your response. No, okay. So we have designed this circuit right here. And now we will consider the T type of flip flop. So what is this T type of flip flop? It is a single input version of a JK type of flip flop, and this T type of flip flop can be obtained, and this JK is tied together, and it will give you the toggle input. That means it is changing continuously the output state. It is changing the output from 0 to 1 and 1 to 0. Okay, so let's see the output. Okay, this is the JK flip flop. As you have already completed this JK flip flop in the previous slides, we are using these two cross coupled NOR gate, and these two AND gates are used right here. We have provided the feedback, okay, to this JK type of flip flop, and right here we are not using the two inputs. We are using only one input, which is T, and that input is provided to both of these AND gates, and you will get output accordingly. Okay, so this is the graphical representation of your JK type of flip flop with the help of T input, and it will give you the output for the truth table. As you can see, T has only two states, either it is 0 or 1. So either it will give you the output Qn, and qn bar as the output if you provide t input as 1. And we can consider this input as hold state and reset state. Okay, so continuously it will change its location from 1 to 0 and 0 to 1. Okay, so let's see the truth table from this particular characteristics table. From this characteristics table, we have the two inputs. One input is T, and one input is taken as output from Qn. So how many possible combinations are there? Four possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. Okay. So this is the output combination from this JK type of flip flop. You can derive this expression, and you will find the one location. Okay, so this one location is present at this point, and this point you have to make a truth table, and you have to create a K map for this. So T and Q N, these are the two inputs. So T is changing from T to T bar, and Q N is changing from Q N to Q N bar, and you have to place the one value across this K map. So where is this one value? T bar and Qn. So this is T bar and Qn. This is your first one. Then second one is T Qn bar. So T Qn bar. This is your second one. So there is no possible combination right here. So we will represent these values at T into Qn bar. This is your first. Then plus this T bar into Qn. Okay, so T bar into Qn, and this is second one, T into Qn bar.